Okay, here we go. Now, I'd like to explain the binary addressing scheme and why we would need to use it. So for shop job 901, 1001, and 1101, all we needed was input addresses and output addresses. And that worked fine to solve those solutions. But now that we are in 1201 and pretty much all the shop jobs from now on, we're going to need to use binary addressing. So just to review, the binary addressing is an address that is physically not tied to an input terminal or an output terminal. Remember, our addresses that start with I:0.0 are our inputs that come in on the top of our PLC, up here at the top. And so that's these registers here. Okay, so those come in at the top, and this very first word right here is the row that we have here at the top. Okay, and our output addresses here are our output addresses that are here on the bottom. Okay, so from left to right here is going to be from right to left in this very first word, and left to right here at the top is going to be our right to left in that table. Okay, so that's what we've used so far, but we're going to need in 1201 and beyond to use this binary addressing scheme. So the best way to explain it is by giving examples. So I'm going to go ahead and create a rung here that's just two connections. This one's going to be our green push button. Okay, so we're going to use, this would normally be the green push button in shop, the not the bottom one, but the next up. And here I'm going to go ahead and type in a binary address. So I'm going to use B3. If you notice over here, it's B3 is the file number. And then I'm going to hit a colon. Now, normally on an input or an output address, we'd have to put in the slot. Remember, this is slot 0 at the PLC, and then the cards that you add on there would be slot 1, slot 2, slot 3, depending on where it's physically connected in. Well, here, because this is internal to the PLC, there is no slot, so we're going to skip right to the word. We want the first word, which is going to be 0, and then we have our delimiter for our bit, and we're going to go to the very first bit. Okay, so that's going to give us a place in memory to store our decision. So we have a description that we can give this, and I'm going to call this green push button pressed. Okay, and I'm just going to call this PRS, green press. Okay, and we'll go ahead and download this. Okay, okay, so the rails being energized on the left and the right side, being that highlighted green, lets me know that I'm online. And I'm also have a spinning ladder diagram here in that little upper window in the RS Logic software. That also tells me that I'm online as well. Okay, so now I'm going to come over here to the trainer, and I'm going to push that green push button. And if you notice, the green press binary bit is coming on. So that is mimicking exactly what's happening with the input address. So a student might ask, well, that's fine, but could you just use that input address for that binary bit? And the answer is you can. So let's extend this out and see how we could make the binary address something that's a little more meaningful to us. So I'm going to go back offline here. and I'm going to select where I want the focus to be. So when I select an instruction up here, it is going to be referenced on where my focus point is. So remember, wherever your focus point is, whatever you hit next is going to go to the right of it. So if I hit this, it puts a sub rung to the right of that, and then I have to grab this and pull it over here. So I have a holding circuit underneath my start push button, and I want to, I change my focus from that side of the sub rung over to the left side, and I'm going to type another instruction here, and that is where I'm going to put my holding set of contacts. Now, physically, there are no contacts here. This is just an instruction, but I want that to evaluate to true whenever this is true. So there's a quick way to type in the address. I could come here and I could type B3:0/0. That's a lot of work. And so what I want to do is just click on the address that I already know that I want there. And in this black section here, the highlighted black, if you just drag that over close to your instruction, you'll get these little boxes next to the instructions. And if you notice, if I get close enough, it turns green, letting me know that that is where it's going to paste that instruction. So now what we have is a holding circuit. If I push the green push button, it's going to energize this, logically. It's going to set that to a 1. And as soon as that evaluates to 1, this will evaluate to 1. And I now have a nice little holding circuit that is going to keep that output bit on. Okay, so let's download this and see how this behaves. Yes. Okay. So here, if I push the green button, I can let go of the green button now, and if you notice, the B3:00 is holding that decision in. So that's one of the reasons why we call it a holding circuit. We don't have to hold the button down anymore. That is now physically holding that decision in. So that could be a decision to start a motor. Well, if that is a decision to start the motor, we could use that later on in the program to actually energize either a control relay if we're talking about a single phase motor, or a motor starter if we're talking about a 3-phase motor. Okay. And of course, we would want to add in some other functionality like a stop button and probably an emergency stop button. But I think you are all pros at understanding that logic. And of course, the disablers go all the way to the left. So you would insert them to the left of this. But that kind of gives you a concept of why we would need that actual push button, or that binary in our circuit. Okay, so what we have in Shop Job 1201 is we have 2 push buttons, right? We have the 2 enabling push buttons, 2 disabling push buttons. The e-stop and the stop are disablers, and the green push button is an enabler that we want to run the motor, much like what this B3:00 is showing us. But the yellow push button, we just want to jog the motor, okay? But they're both going to the same device. And if they're going to the same device, if I push the jog and this circuit is only paying attention to the set of holding contacts coming back from the field, it would stay running. So we would negate our ability to have a jog function. So let's look at how we can incorporate these binary bits to be able to add in both functionality for one final control element. Okay, so we have our holding circuit here. Of course, we would extend that to have other functionality like stop and e-stop. But let's go ahead and add another rung in here. And this one, we're going to use the yellow push button. Now, of course, I had predefined those, and if you're using your template that we set up in a previous video, you could do that. If not, you could just use these addresses, I:0.0/5 for the green push button, and I:0.0 0.0/6 for the yellow push button. Okay. And so here, what I want to do is I want to store this is going to be a different decision that I want to store up from this one. So I'm going to come here to B3:0/1. It has to be a different bit number. Okay. And then this one is going to be my yellow push button pressed. Okay. And we'll call this one yellow PRS. Okay. So now we have two different types of decision. We have two different buttons with two different functions and two different types of decisions here that we want to make. So here, if I push the green button, I'm going to hold that decision in. If I push the yellow button, I'm not going to hold the decision in, much like I did up here in my previous example when I didn't have the holding circuit. Let's go ahead and download this and give you a visual on how this works. Okay, so here is my running program. I'll go ahead and push my green push button again here. And if you notice, that held in that decision. Okay. Now, if I push my yellow push button, it's not holding in that decision. Okay. So let's think about how we could use those two different functionalities there to ensure that we can get out of those two buttons a running output and a jogged output. So I'm going to go ahead and stop this here. I'm going to go offline. Okay. I'm going to need to zoom out even more here so we can see all this. So I'm going to add another rung in here. And this one, we're going to actually put to something we can see on our training panel. Let's see. We'll do a 0.0/1. And this is going to be for our white pilot light. And then, actually, because this is going to make the program so big, it's going to be hard to see it on the video. I'm going to back out here for a second. I'm going to show you a little trick, and you've done this in manual motor controls. If I actually highlight or put the focus on that instruction, I can actually put something in parallel by using this branch down sub rung here. And now those two items are in parallel. Okay, let me do that again just so you understand what I'm doing. I have the focus on where I want the instruction to go to the left of, right? And so I'm going to hit this little sub rung right here, the rung branch, and then it pushes this over here, and we know that we can't have anything to the right of the output address, but what we're going to do is we're going to drag this around. I don't know why it's not. There we go. We're going to drag this over to where it is going to be, I'm putting a branch in parallel with my output. Okay. So now here we can actually not, at the same time we energize that, we could also turn our light on. Okay. So we are going to here go to I:0.0/1. Okay, so that's my white light. Oh. Hopefully you caught my mistake there. I said I. It should have been O. I knew there was a problem because I'd already typed in a symbol and a description there. So we can actually see this a little bit closer now. So whenever this remains on, the white light will also come on. And then here, I will put a sub rung here. And I will put an output instruction here. And this will be the blue getting ahead of myself. Icon 0.0/2. Okay, and this will be the blue. Okay, so we have, we're going to have some indication that we'll be able to see over here when I download this. Let's go ahead and check the program, no errors. Let's download the program. Okay, so I'm going to do this in reverse order. I'm going to push the green button. I'm sorry, the yellow button. And you notice the light is just jogging, okay? It's not staying on. Here with the green push button, the light does hold and stay on, okay? So hopefully that kind of gives you some ideas of how you could utilize this on job 1201 and moving forward. I hope that helps, and we'll see you in the next video.